Hey guys, alright, so I wanted to go over these graphing of logarithmic functions here in this video, and so you can rewind it and go over it as as you wish. Okay, so as we see up here in these boxes, with the exponential functions, remember y equals some base to the x. Let's go boop. Okay, so with these guys, y equals any base to the x. We wanted to make this x first a 0 because 2 to the 0th is a 1, and make it a 1 because 2 to the 1th is itself 2, so it makes it handy dandy points to plot. But with logarithms, now we want to pick x values that make the of number, okay, the argument, it's called the of number. We want to make any base here. We want to make this guy handy dandy numbers, so we'll pick 1. We want to plug in numbers that make this of number 1. Okay, so and the second point you should plug in is make this of number the same as your base. Okay, because that way all of this becomes a 1. If you make your of number a 1, all this becomes a 0. All right, so those are the two things we're going to look for. And also we're going to see that there needs to be parentheses for the asymptote to shift to anything other than the y-axis. Okay, without any shifting, your asymptote is the y-axis, and we only shift left and right from there if there are parentheses, like in this problem. So let's go back and let's redo the parent graph here. Okay. All right. So in red here, you see these are log graphs. They sweep along a vertical asymptote and then curve over. They don't curve over on itself like this, but they curve and then extend to infinities up and beyond. Or if your base is in between 0 and 1, your base is, let's say, a fraction, log base a fraction, then it'll descend along a vertical asymptote and curve over this way. Okay, so those two situations. All right, so let's do the parent graph again. Okay, so we cannot take logs of a negative number, and we can't take logs of 0 either. So therefore, if this is unmodified, we see that we will have a vertical asymptote right here along the y-axis when x equals 0. Then my first handy dandy point is if I can make this argument, aka the of number 1, then this whole darn thing becomes 0. So I will plug in a 1 and the whole darn log will become a 0. If I can make this argument the same as my base, in this case a 2, then the whole darn thing becomes a 1, a value of 1. So I'll type in this case a 2, and the result will be a 1. So let's plot those, 1, 0, over 2, up 1, and voila, my parent graph of a logarithmic function is something like that. Okay, let's do the next one. Two ways to look at this sucker. Okay, so well, we'll start with this. The vertical asymptote hasn't changed, so I can't take log of 0 or anything negative, so I'll have a vertical asymptote right here along x equals 0. Okay, so vertical asymptote is x equals 0. I'm going to plug in a 1 here, just the same. 1 comma, if that's a 1, doesn't matter what this base is, the whole darn thing as a value of 0. Now in this case, now I want this to be the same as my base, so I'll plug in a half. And when my log base a half of a half will be a 1. Okay, let's plot those. 1 comma 0, a half comma 1, and you see that now, because this base is a proper fraction, it will descend along that asymptote and curve over this way. Let's look at this one more way. Let's look at this as, okay, we can call this log base 2 to the negative 1 of x, and we know that this exponent on the base, this negative 1, will come out here as 1 over that. So another way to look at this is negative log base 2 of x, right? These two are synonymous. So now in this case, if I make this argument, the of number, the same as the base, then I would plug in a 2. Log base 2 of 2 is a 1. I have this negative out here, and I'll have negative 1. So that's a third point. You don't have to do this, but if it helps you, then go for it. And you see that's consistent with, whoops, it's hard to write with this pen. Jabam, jabam. Okay, something like that. All right. Whoops. All right. Whoa, I don't know what happened there. Okay, moving on. Let's go back to this page now. Okay, so now remember this. There must be parentheses. There must be parentheses for the asymptote to shift left or right. So in this case, there are parentheses. And if that says x plus 2, then that means there's a vertical asymptote at x equals negative 2. Okay, set the argument, set the of number equal to 0 and solve for x. So now we see that there's a vertical asymptote at negative 2, and we'll draw that. Okay. So therefore, the whole graph has shifted to the left 2. That's very consistent with everything we've done all year, right? Shifted to the left 2. That means our vertical asymptote is shifted to the left 2 as well. Okay, so now let's pick 2 points, 2 handy-dandy points, and I will pick, I want this all to be a 1, so I will plug in negative 1 for x, therefore negative 1 plus 2 is 1, and the whole darn log becomes the value of 0. Now I want the whole darn log, I want the argument to be the same as the 5. So I'll plug in a 3. 3 plus 2 is 5. Log base 5 of 5 is a 1. And I have my 2 points. Negative 1, 0. 1, 2, 3, comma 1. Let's see if I can make this happen. Kind of crazy drawing with this electronic pen, but there you go. Something to that effect, okay? All right, so look for those parentheses. If you don't see parentheses, then there is no horizontal shift. Now, don't fall for this. This is not shifting to the right 1 because there are no parentheses, right? So, right here, no parentheses, therefore no shift of the vertical asymptote. So you still have a vertical asymptote at x equals 0. It's still the y-axis because there were no parentheses. That negative 1 right there is not a horizontal shift. That is your k. That is not an h. That is your k. This guy, this 2 is your h because it's in the parentheses. This -1 is a k. That's a shift down 1. Okay, so make sure and look for that. All right, so now I'm going to want this. I'm going to put this guy in parentheses to make it clear to myself that that's what I'm plugging in for. And then after the fact, I will subtract a 1. So I'm going to plug in a 1 because I want this argument to be a 1. Therefore, this whole log becomes a 0. 0 minus 1 is -1. Okay, now I'm going to plug in 1/3. Log base 1/3 of 1/3 is 1. 1 minus 1 is 0. All right, let's have some fun, and let's just look at it the other way that we've already talked about. The other way we could write this is negative log of base 3 of x, and then a -1. In that case, I'd plug in a 3 here. Log base 3 of 3 is 1. Negative of 1 minus another 1 is -2. Okay, so we have 3 dots. You only need 2. I'm only going to ask you for 2. So to the right 1, down 1. To the right a third, up and down 0. And that green dot there is to the right 1, 2, 3, down 2. Okay, all consistent. And let's see if I can again draw this. If I can touch that point, and over and down. Okay, great. So while we're here, let's take a look-see, at our domain and range. The domain would be what? It'd be not including 0, right? There's our vertical asymptote at 0 on to infinity. Our range will be lower to higher. See how this guy is shooting downwards and to the right forever, and he's shooting up forever to the left. So our range is -infinity to infinity. -infinity up to infinity. Okay? When is it increasing? When is this sucker increasing? When is it going lower to higher from point to point? Never. It is always going higher to lower. So it's not happening here. Decreasing. That interval back to the x values, remember, it's the same as the domain. Along the whole domain, it is decreasing. Makey sensey? Okay, I could ask you x-intercepts. There's the x-intercept right there. I could ask you y-intercepts. There is none. It never touches the y-axis. There is no min or max. All those questions we always ask, okay? All right, moving along. Okay, let's see how we can crank this guy out. Okay, graph this function. All right, well, I want to make this argument here a 1. Remember, it never does me any good to make it a 0, because that's actually it does, that's my vertical asymptote. My vertical asymptote is when your argument is 0. So that would be at x equals -1. My first point I'll plug in is what should I make it? So I want it to be a 1. I'll plug in a 0. Plug in a 0 for x. That makes this a 1. Log base 2 of 1 is 0. 0 minus 3 is 0, -3. All right, next point. I will make this the same as the base. So I want to make it a 2. So I'll plug in a 1 to make the argument a 2. Log base 2 of 2 is 1. 1 minus 3 is -2. Awesome. So here we go. I'm going to have my vertical asymptote here. I have 0, -3. I have 1, -2. and I can make that curve. Jabam, jaboogie. Up jump the boogie. Alright. So now let's do this one. Okay, my vertical asymptote is at x equals 2. It's in parentheses. There's that sucker. My first point, I want this to be a 1, so I'll plug in a 3. 3 minus 2 is 1. Log any base of 1 is 0, plus 1 is 1. Okay, this next one's kind of weird. I want this to be a half, right? I want this of number to be the same as this base. So I'm going to take away a 2, so I'm going to actually plug in a 2.5. 2.5 minus 2 is a half. Log base a half of a half is 1. 1 plus 1 is 2. If you want to go the other way with it, remember what this is. This is negative log base 2 of x minus 2 plus 1. So in that way, I can make this a 2 by plugging in a 4. 4 minus 2 is 2. Log base 2 of 2 is 1. Negative 1 plus 1 is 0. Maybe you like that way better than this 2.5 stuff. I don't know. Up to you. So that's 4, 0. The other 2 points were 3, 1, and 2.5, 2. All of them are consistent with this curve descending from heaven along the asymptote, curving over and off into eternity that way. All right. Domain and range. Here's our domain. Domain is -1 to infinity. This guy, range is -infinity to infinity. Domain on this guy is 2 to infinity. Range is -infinity to infinity. Maybe you're starting to see a pattern here. Your range on logarithms will always be all real numbers. -infinity to infinity. Okay, now we got this madness. And let's see what we can do with this. Okay, so we have this this function here, right? We want to graph it. So where is our vertical asymptote? Well, there's no parentheses. It's not plus or minus anything. Whoops, vertical asymptote. So we have it right along the y-axis. Whoops, sorry. Shouldn't be curved. All right. Now I'm going to plug in a 1 for d. Log base 10 of 1 is 0. 0 times this number is still 0. And I get 0.159. Great. Now I'm going to come over here and plot 0.159. So I'm going to make these, I'm going to make this 0.1, this guy 0.2, this guy 0.3. All right. So I'm going to come over 1 and up 1.5-ish. Okay, so 1, 0.159. All right, then I want to make this a 10. See how that's log base 10? Here, let me erase this. Remember, this is log base 10 if it doesn't have a 10 written there. So I'm going to plug in a 10. 10 comma something. Log base 10 of 10 is 1, and I have 0.118 plus 0.159, which is going to be 0.277. Okay, so over 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up 0.27. And that's enough. So I can see now the trajectory. Whoops. That's just my bad electronic pen. But it, shouldn't touch the asymptote, should it? But you get the idea. With your pencil, you'll be more skilled. All right, and that's that graph. Notice how it's a normal log graph. It's coming from lower, bending over to the right, higher, because this is just a normal log base. Base is greater than 1. Okay, now it says estimate the average diameter. We're going to solve for d if the slope is 0.2. So we can just plug in a 0.2 in for s, right? Your slope is 0.2. Let's see if we can do it algebraically instead of graphically, because graphically it's not going to be very accurate unless I have a calculator. So 0.2, 0.159 plus 0.118 log of d. Okay, let's combine like terms. I'm going to subtract this guy, kick this bad boy over the other side, and get 0.041 equals 0.118 log of d. Then I'm going to divide by this guy, 0.118. I'm going to move this log, no, I just won't do that. I'll go 0.34746 equals log base 10. I'll go ahead and write that in so it makes it clear. Now I want to solve for d, right? I want d. I want to isolate d. This is where I convert from logarithmic form to exponential form because I want to liberate this guy. So 10 to this exponent will equal d. All right? So d equals 10 to the 0.34746. All right? You crank that out in your calculator. Your diameter will be 2.2257 whatevers. What is it? Diameter, I can't remember what it is. Millimeters or whatever it is. Okay? Units, we'll say. Units. Okay. Groovy, groovy. Moving along. Let's do, almost done here. Example 9. Okay. Now we have this guy. We have this negative here. Remember what that means. It's grouped within the functional group. Okay, that negative on the x will flip it left. Flip the whole graph. This graph right here will flip this way. So I expect to have something that curves and then down along an asymptote. Okay. Now we could factor this negative out but remain within these parentheses. We could do that. Well, I'll go ahead and write that so you know what I'm saying. I'm saying negative. We've done this throughout the year as well with other functions. And this tells me that my vertical asymptote is at x equals positive 5. And this guy tells me he's flipped left and right. Do I really need that? I mean, I could just take this whole junk right here, set it equal to 0, right? Remember, the vertical asymptote means when the boundary, log, any log can't be 0, so I could just go negative x plus 5 does not equal 0. Basically, it means does not equal 0, and solve for x, and we'd still get x equals 5 that way as well. So I don't really need to factor this out unless I'm asking, you know, how's it flipped and all that stuff. So let's just go back to the original. I'm just going to go back to the original and do our, whatever you see is easier. This form or this form, it doesn't really matter. So log base 2 negative x plus 5. I'm going to pick a point. I'm going to pick a point that's going to make this a 1. Well, what point would that be? That would be 4. I mean, what value for x? That would be 4. If that's negative 4 plus 5 is a 1, the whole darn log becomes a 0. Now I'm going to plug in something that's going to make it the same as the base, make the argument the same as the base. So I'm going to plug in a 3. Negative 3 plus 5 is 2. Log base 2 of 2 is a 1. Look at that. So let me place this vertical asymptote at 5. 1, 2, 3, 4, 5. Okay. Let me place this dot at 4. 1, 2, 3, 4, 0. this dot at 3, 1. 1, 2, 3, 1. And looky there, the dots did the work for me. I expected it to be flipped left and curve like this. I expected it to curve like this, and sure enough, it does. Along this asymptote, through those points, and on, over, and onward. Now in this case, the domain will be negative infinity up to my asymptote of 5. Of course, not including 5, because it can't be 5. And my range, even though it's flipped left and right, doesn't change. Lower to higher, all these y values will have points on the curve, negative infinity to infinity. All right, last page, last two. Now we have ln's, very, very, very common in calculus, perhaps more so than common logs. So, but nothing changes, okay? Nothing changes except for, we just have to remember that's simply log base e. That's all it is. It's just like a 2, except it's a 2.7. So I'm still going to see that my vertical asymptote is still, not shifted. It's still x equals 0. So that hasn't changed. Nothing's different there. It should be right on the y-axis. I know I didn't draw it so well. Okay, I still want this to be a 1, so I'm still going to plug in a 1. Log base e of 1 is still 0, just like everything else. So 1 comma 0. But the difference here is, now I want this argument, this of number, to be the same as the base. So I will plug in an e. I want you to write an e. Do not write 2.718. Write the letter e there. And then log base e, of course, is 1. Now when you go to plot the point is where you're going to have to know that's 2.718. So you go over 2.7, up 1-ish, and up 1, and you have that point right there. You ascend along the asymptote from below, curve over, and it looks like just any other. It looks just like the graph with a base 2, except it's just slightly different here. Instead of 2, 1, it's 2.7, 1. That's all. All right. Domain, range, everything's, the same. Okay, and finally, last problem. Okay, so we have this guy, right? He's gonna flip it how? He's gonna flip down. He's gonna flip it how? He's gonna flip left. Okay, that's a shift up 2 spaces. It's shifted left and right 0 spaces. It's log base e. Okay, so let's go to town. That's what I expect. Let's draw the progression. Here's a normal log. Okay, this guy is going to flip it down. Flip this guy down. So now the green will replace the blue. And then this guy is going to flip him left. So instead of the green, it's going to look like this. It's going to look like the red. Okay, the red's going to be the final answer. But let's just have our points do the math for us, okay? Okay, so my vertical asymptote is x equals 0. See how that's plus or minus nothing. So it's still along the y-axis. Okay, my first point, I will make this a 1. So I'm going to plug in a -1. I need a negative of -1. I don't want to take ln of -1, so I don't want to plug in a 1. I want to plug in a -1, so it's ln of +1. Does that make sense? So a negative of -1 is 1. ln of 1 makes this whole ln 0. Negative of 0 plus 2 is a 2. Finally, I want to make this argument the same as my base. I'm going to write this little e here to remind me that's log base e. That's what ln means. Okay, so what do I have to plug in here? Do I want to plug in an e? No, I want to plug in a negative e. So this negative will cancel with the negative. So negative e will make this ln. So log base e of e is now 1. Negative of 1 plus 2 is a 1. All right, ta-da! I now have my 2 points. I have negative 1 comma 2. I have negative e, so negative 1, 2.7, comma 1. And voila, I must descend along the asymptote, curve through here, just like I predicted. The shape I predicted was that red one, just like that, right? And there it is. All right, guys. See you in class.